Good morning, ladies and gentlemen. Hi, my name is Oscar Gutierrez.
And my name is John Ritchie.
Did you guys know that last year tens of thousands of people were placed under evacuation orders due to wildfires?
Also, I'm sure you've noticed how every single summer there's new headlines about heat waves and like tarmac melting in other regions of the world. Every single year for the past 10 years, we've set global high temperature records.
A consequence of this temperature is an increase of crop failures. Go back. Can you please go back to the previous slide? So we show this graph to show how over the past 2 decades the fires have been increased, and this is the region of where fires are most common and by province.
That region is also especially impacted because the northern regions are fluctuating more greatly due to climate change. So those forests are getting drier than they ever have before. As my partner Oscar mentioned, the increase the risk of simultaneously crop failures around the world. So, climate change. Everyone hears about it, but the people who are responsible, the nations, they don't seem to take responsibility for it. So we propose that
Some of the nations that are responsible for this are big nations like the US, China, and many of the European countries.
the wealthy industrialized nations of the world.
There are actions that need to be taken, and they're no secret. These actions are well documented and available to the public. The first steps that these nations need to take is a reduction in emission reductions, carbon neutral, and a net zero, and finally with carbon negative emissions.
However, political will has been slow in taking these actions, and as the industrial nations drag their feet in cutting emissions, the damage due to climate change mounts. So that's why we believe that drastic action should be taken.
There has been multiple proposed projects, and during the next few slides, we'll be summarizing each of each proposal.
One particularly infamous example of this drastic measures taken, also geoengineering, was ostensibly a strategy to increase salmon yield, but it's well known within that community that dumping iron oxide into the ocean, a mineral that plankton which absorb mass quantities of carbon dioxide when fed this iron absorbed from the atmosphere. However, this is without drawbacks.
However, some of the drawback is that the potential algae blooms, as well as disrupting the ocean ecosystem.
The advantage this has over other strategies is that iron is cheap compared to other methods that were mentioned. When a volcano erupts, it's well documented that it causes a sort of winter drop in global average temperature for a little while. Some scientists have proposed or theorized that deliberately spreading these particles high in the upper atmosphere will help reduce the warming greenhouse gases.
However, the drawback of this proposal is that once the dust has been sent off, it cannot be retrieved.
And then, if there was volcanic eruption, there is a risk of overshooting the target of pre-industrial temperatures. Another similar proposal to this, which involves planes, is distributing chemicals that cause clouds to form in the sky, particularly over the oceans. The clouds are much more reflective than the oceans and reduces the amount of energy absorbed. This means that less energy means less heat, and the world would warm less.
What about when it blows away?
The clouds would need to be continuously replenished by planes, so planes would need to fly near continuously distributing these chemicals.
Making this unsustainable and very expensive.
In addition to that high cost of manufacturing those tons of chemicals that would be required, flying the planes, which adds more greenhouse gases, creating clouds everywhere might cause droughts in other places by preventing the moisture in the atmosphere from reaching where it would normally go to.
We built this model for you guys to show you guys what one of the solutions that we came up with.
Our proposed solution is shape satellites in orbit about the Earth. Specifically, Lagrange Point 1. The James Webb Space Telescope recently launched to Lagrange Point 2. Lagrange Point 2 is a point where you always stay with the Earth between that point, Lagrange Point 2, and the Sun. We suggest that these shape satellites be stationed at Lagrange Point 1, where they will always be between the Earth and the Sun.
This is a demonstration of what the satellite may look like. Built of aluminum. The reason why we picked aluminum is because it's reflective and it's very cheap. With this comes the feasibility of our new implementation. We're going to cover the cost, the quantity of satellites needed, the manufacturing process, and the technology required.
The image up on screen is of the only technological implementation of this that has been tried in the real world. This is Zmeda, Russian space mirror. Its concept is controlling solar radiation, but it wasn't reflecting it away from the Earth. It was using it to illuminate cities at night. But our concept would be similar in reverse, to reduce the amount of light hitting the Earth. Initially, we believed that these satellites could be launched from the Earth's surface. However, analyzing the cost of launching materials from the Earth's surface, this was deemed unviable to the high cost per kilogram. Instead, it's cheaper to launch the facilities to build these into space and build them in space.
In this graph, we can see over the years, the space exploration has been made cheaper. And with if we keep improving this over the years, it can be available to the public.
So, when we say we'll launch satellites to space and cool down the Earth, it sounds preposterous, and to reduce the temperature of the Earth back to pre-industrial levels, we would require about 4.6 million square kilometers of satellite coverage. The amount of satellites required to achieve that goal would be somewhere between 100 to 1 million satellites.
Why is the number of satellites so uncertain?
That's because it's determined by the design of the satellites. At this point, we're uncertain how large each individual satellite would be. If each satellite is 1 square kilometer, we require 4.6 million of them. If they're a quarter in, let's say they're squares, if they're a quarter in the dimensions of the square, you require 4 times as many satellites.
Moving on to lunar industry. So you guys may think this is a far-fetched idea, but in order for this to happen, we need to take manufacturing to the moon. And one of the ways to make this happen is by, currently SpaceX is working on the project is to send materials that are very heavy, and so we can
Yeah, pictured there is the Starship launch system, more powerful than the Saturn V. It would enable, and also reusable. It would enable record low launch costs. Still not low enough to enable us to build the satellites on Earth, but cheap enough to enable the launch of industry to manufacture on the moon. In addition, there's high concentrations of aluminum on the moon discovered by NASA. And the technology is also being investigated. There is a 3D printer printing using lunar dust.
Some of the perceived drawbacks. I know what you guys might be thinking. This is a great idea, but this just adds more junk in space. And one of the solutions, and John will explain some of the solutions, how we can avoid that.
So, space junk. We hear a lot about space junk. Fortunately, due to these satellites being positioned at Lagrange point 1, Lagrange point 1 is beyond the orbit of the moon. However, most space junk is concentrated about 300 kilometers above the Earth's surface, or 1,000. Lagrange point 1 being 1.6 million square kilometers away from all of that doesn't pose a risk to the space junk. In addition, if there's collisions, these satellites are moving very slowly, so that if they do collide, there isn't the deadly cloud of shrapnel that occurs in low Earth orbit when two satellites collide very quickly.
Another drawback of this is the amount of years this may take to make this achievable. And although it's uncertain, we know that it's achievable because of all the technology that's being developed at the moment.
Also, the time scale that we're facing isn't on the scale of individual people or governments. We're talking about the entire future of the Earth. So at that time scale, where 100 or 200 years is the impact and consequence that we're considering, the implementation time of 20 years isn't that large. In addition, the satellites being so far away means that the satellites do not cast a direct shadow on the Earth. Instead, the angle that the sun's rays form around them just only reduces the light intensity on the surface of the Earth instead of casting dark shadows.
This is not a permanent solution to the problem, and the technology is still in development.
Due to the satellites being outside of the Earth's ecosystem, it's mechanically solving the problem, not solving, it's treating the problem, not curing it. If we continue to release greenhouse gases, the greenhouse effect will also increase in magnitude, and we will require more satellites. So this satellite solution is not a solution, it's to give us more time to address and reach our climate goals.
Next, we have the social considerations. With this proposal come up also social considerations. We believe that this proposal can change the way how people see space, changing their perspective to a place where they can live and work. With the implementation of this project, the public may feel that the global warming has been solved. However, this is not true.
In addition to all of that, right now, a lot of people feel like space is a dead end. We went to the moon in the 60s. We're barely even reaching back to the moon now. With an entire space shield defending ourselves from our own consequences, people might feel that space is a place full of opportunity, a place where we can continue to progress instead of a sad dead end.
Due to the international effort, this project would cause the governments and space agencies to collaborate and come with the idea and make it happen.
And in order to avoid the sort of inequality / tyranny that industrial nations have inadvertently inflicted on less developed nations that didn't emit greenhouse gases, it's necessary to have the entire globe's input through a body such as the UN in the control and management of the solar shielding.
Now we're going to talk about the economic side. So we said that this will change the way how people see space. This will create new jobs, either by maintaining the new technology that we created, as well as people working there to make this technology. There is a large initial cost to this project. However, this is offset by the economic and stabilization of climate.
Environmental impacts. Naturally, this is an environmental proposal. We're aiming to manipulate the environment with this project. However, there's still risks involved. There's a risk of changing how weather patterns form. The primary driver of weather patterns is from the equator to being hot and the north being cold, or the far south. The poles being cold and the equator being hot. This space shield would cause the equator to become cooler disproportionately more than the poles. This is because the sunlight reaches the world as a wall, but at the poles, it's more stretched out. So this amount of sunlight is stretched across this area here. So when we reduce this by the same percentage as this here, this is more impacted.
That's why some places in Iceland may only receive 4 hours of daylight.
So, however, while this is certainly a consideration, this is something we're experiencing right now from climate change happening with extremely hot air from heat waves rising up to the poles and disrupting those stable climate patterns. So this consequence is probably, with what we stand to gain from the implementation of this proposal, the consequence being potentially a minor version of what we're experiencing right now is not a showstopper. An additional consideration is that plants use light. They grow using light. So a reduction in light reaching them reduces how productive a plant can be. I think this is also a serious consideration. However, the primary impact that humans are concerned about is plant-like food crops. By stabilizing global temperature and reducing the risk of crop failure, global crop yields are improved, and this consideration is also not severe enough to negate the benefits of implementing this proposal.
With our conclusion, the global impact, global effort, and cooperation will be required. While this project faces challenges, it's still achievable because all this technology is still being developed. And through our common goal, humanity can work together as a whole to preserve the planet.
Bring it back down to pre-industrial.
But then the implementation piece, because I guess if it's slow implementation, slowly you're bringing the temperatures down, it would allow life on Earth kind of to adapt to that. So the flora and fauna, everything can adapt to that. If it's, I guess, implementation like that, where you're bringing it down suddenly, that would have impacts and maybe not allow the native plants or overall food chain to get impacted, right? So not to impact. Not to, I guess, adapt to that if it's done in a drastic manner. Or would that be the correct implementation?
The time scale for construction would be over decades, so the reduction would not be immediate. It would be slow enough that it would not be a shock.
Right. Okay. And just one other question. Would these satellites be communicating anything back to the Earth, or is it just, it's like a manual phone that they would be communicating with geolocation and stuff, but other uses of things?
They would have communication required to ensure that they're functioning as required, like holding their position, but nothing beyond that.
Yeah, obviously a really interesting topic and I guess I could try something. Is this something that like is like not NASA, but like is somebody actually looking at this system somewhere this like
There was,
it's
yeah, there was an MIT study about producing bubbles that float on the moon and sending them to Lagrange point one as well.
okay, interesting. I guess like the question that I have from again civil engineering standpoint, how do you get them to stay there?
They require a station to be thrusters, so the pressure, there's such a thing as a solar probe. The light has a pressure, so they would be pushed out of the way by solar winds. They need thrusters to hold their position where they are.
So we also have to be refueled.
They would have a lifespan because they would also wear over time for micrometer meters, so they would need to have to be maintained.
That was kind of actually that was one of my questions. How does the aluminum like micrometers and astronauts like what's the implication there? Like do they like I don't know, I'm just imagining you getting like hail damage essentially, right? And they lose their or I guess it is it's reflecting or something blocking the sun.
Yeah.
To solve the issue, we plan to maintain it and do inspections on it and yeah, maintaining the.
How, you said it's like, I'm like imagining this like spatial scale to me, right? So 1.6 million kilometers, I think was the number you guys quoted, and the moon is like 280,000 kilometers.
It's about 1.5 times the area of India.
Right, but to get to the Lagrange,
Oh.
like what are we talking about in terms of like commute time, I guess, right?
So that's
Or with current technology.
that's another advantage of being manufacturing on the moon is the moon is 1.2 million and the Lagrange point is 1.6 million. So the moon is relatively to the Earth close to Lagrange point one, and if you were launching them from the moon, it would only take a few weeks to get there.
That's good.
Have you guys looked at the start, I just thought of if you're blocking the sun, I thought of dinosaurs and how they were this thing. Have you thought of a material that would let in some of the, reduce the rays that come in, but still allow enough light to get in so you're not causing depression and you can see it here, or production of plant growth, or have you looked into that, or do you know if the study that MIT is doing has looked into that?
The total reduction of sunlight would be approximately 1%. So where the seasonal depression comes in is where it's about like it's the winter time here, so it's like 50% more. It's like spending most like 70% of your time in the darkness, whereas like 1% overall wouldn't be enough to trigger effects like seasonal depression.
Or what about plants? But I'm just thinking kind of other material that's studied. I'm just curious because it's focused on the
We decided aluminum simply because it's the most abundant and the cheapest, and it's also found on the surface of the moon.
and has it been studied done on optimizing the amount of time that you have to block in the rays for it to work without blocking it too much? You mentioned the study that have they looked at that? Like, how would you, because, I mean, think about it, the sun been there, we lived as humans and plants for millions of years. Now you're trying to change the cycles. How would, what would that be the sweet spot of making a change without causing harm?
So, climate or rather not letting go of because of the blanket of greenhouse gases. So the area is calculated to, when it's to bring it down to pre-industrial levels, it's to block the equivalent of the energy that's being absorbed, so it maintains the equilibrium. It's to try and pretend like nothing happened, or trying to stick a band-aid on it.
I was looking at your prototype here, and it looks like the planets can move. Is that theoretically the goal? Is that you could tilt them different directions so that you change the amount of sun that you're producing?
Yeah, the idea is, that's another pro of the satellites is they're retrievable. If something happens on the Earth, like a volcanic eruption, global temperatures drop by a degree, it's possible to pack away the satellites for a while so that we don't throw ourselves into an ice age by accident.
Yeah, that makes sense. So it would be like an origami present, kind of wrapping.
We unfortunately didn't have a fully complete model, but the idea is that there's a there's a cavity in here. So the idea is they'd be launched in a small package, and then they would unfurl.
Okay, now I gotcha. I had the other questions about some other technology that you also brought into the presentation, which seemed super interesting. So the first was about that primary satellite that seemed to be the inspiration for this idea. That was the one developed by the Russians.
The space period.
When was that implemented?
1993.
Okay. And do you know about how much light it created?
I do not know.
Just was curious if that was perhaps then we could consider an almost equal reduction then with this implementation. The other one that seemed really interesting I'd never heard of before was this lunar